So now we have an important question to ask. If we're in a case of equilibrium, we know that means that the acceleration is zero, the angular acceleration is zero, the net force is zero, the net torque is zero. But at what origin should we use to calculate that torque? Remember, torques depend very heavily on what origin we use. So let's consider, suppose there were a force acting on this bridge right here. That's a force. If I find the torque around origin 1 here, I put my fingers of my right hand so that they point along the direction of this radius, and I have to turn my hand so that I can bend my fingers freely and easily at the knuckles into the direction of the force. That means I have to hold my right hand with the fingertips pointing to the right of the page, my palm pointing to the bottom of the page. That leaves my thumb pointing into the board. So this torque, if I use 1 as my origin, is into the board. By contrast, if I use 3, this becomes my new radius. Now I have to hold my hand so that my fingers point, the tips point down and left, and I have to be able to bend my fingers freely and easily into the direction of F. That requires that I hold my hand with the fingers facing down and left and the palm down, so that I can bend my fingers freely and easily into the direction of F. That leaves my thumb pointing out of the page. So if my origin is 03, the torque is actually out of the page. So we see the direction of the torque depends on what origin I'm using. So this is an important question. But maybe we can phrase it in a different way. This bridge is not rotating. Which origin is it not rotating around? And you're probably staring at me thinking that's a really strange question to ask. It's not rotating around any of the origins, which is absolutely correct. Which means, physically, the net torque around any one of these origins had better be zero. So I can use any one of these origins. Okay? That's the answer. How do we know which origin to use in calculating torque? Answer, it doesn't matter. We can actually prove, and I will on the next slide, that if the net force on an object is zero, and the net torque about one particular origin is zero, then the net torque about any origin is zero. Okay? So, we're going to consider this here, and we're going to go to the next slide. We know that the torque on something about point P is equal to the sum of each of the individual torques, which are each individual radius about P crossed into each individual force. Now the torque around point O would be the sum of each individual radius about O crossed into each individual force. But remember, the individual radius to O is just the individual radius to P plus the radius from O to P. So this is the sum of RIP plus RP crossed into FI. Distributing, I get the sum on I of RIP crossed FI plus the sum on I of RP crossed into FI. Aha! Now this is just the torque about P. And here, I can take this out of the sum because it doesn't change. So this is the torque about point P plus the radius to P crossed into the sum of all individual forces. Oh, that's just the torque around point P plus RP crossed into the net force. Well then, if this net force is zero, and this is zero, the whole thing is still zero. Okay? Coming back here, key idea, we can use any origin we like. The best origin is going to be the one that makes the calculation as easy as possible. I'm going to illustrate that in a minute on a particular problem that was done in the text, and I'm going to show how much easier it can be if we use a different choice of origin.